The $30,000 Tesla was supposed to be the game changer. Musk just cut that in half, $14,999 for the Model 2, launching this December. But the real shock isn't the price, it's what's powering it. Tesla's replacing lithium with aluminum-ion batteries, a technology most automakers dismissed as impossible for production vehicles. The numbers are staggering. 300-mile range from just 53 kilowatt-hours, twice the energy density of current cells, and $2,000 cheaper than LFP packs. So why now? What breakthrough did Tesla unlock? To understand why Musk went nuclear with this price, you need to see what's happening in China. BYD sold 3.02 million EVs in 2024. Tesla, 1.79 million. That gap isn't shrinking, it's expanding. While Tesla maintained premium pricing, BYD flooded global markets with $12,000 electric cars that actually work. The Seagull, the Dolphin, the UN Plus. These names mean nothing to most Americans, yet they're dominating the world's largest EV market. And here's what stings. BYD's cheapest models aren't compromised products. They're legitimate vehicles with decent range, modern interiors, and build quality that destroys the old cheap Chinese car stereotype. When Musk announced $14,999, automotive analysts called it impossible. The economics didn't work. Even with Tesla's vertical integration, even with gigacasting slashing manufacturing costs, the math for cutting a $30,000 target in half seemed like fantasy. Raw materials alone would consume most of that budget. So either Tesla was planning to lose money on every Model 2, or something fundamental had changed. The answer wasn't in manufacturing, it was in the battery. Every Tesla ever built runs on lithium-ion technology. Premium models use NCA chemistry. Affordable versions use LFP. The Cybertruck uses 4680 cells. But all of them depend on lithium ions moving between cathode and anode. This created a worsening problem. Lithium prices spiked to $80,000 per ton in 2022, then crashed to $13,000 in 2024. That volatility makes planning a mass-market vehicle impossible. Musk complained about this publicly, and for good reason. You can't build a business around a commodity that swings 500% over 2 years. The deeper issue goes beyond volatility. Lithium represents only 0.006% of Earth's crust. Aluminum makes up 8.2%. That's not marginal. Aluminum is roughly 1,200 times more abundant. Battery researchers have known for decades that aluminum-ion technology was theoretically superior. Aluminum ions carry 3 electrons instead of 1, meaning triple the current flow. Energy density projections hit 500 watt-hours per kilogram, double what today's best lithium-ion cells achieve. Faster charging, better thermal stability, and virtually zero fire risk because aluminum doesn't undergo thermal runaway. So why isn't everyone using aluminum ion? Because until recently, nobody solved degradation. Aluminum ions are larger and more reactive than lithium ions. They physically damage cathode materials during charge cycles. Early cells worked beautifully for 50 cycles, then capacity collapsed. You can't sell a car with a battery that dies after 6 months. The technology needed to survive 1,500 plus cycles over 10 to 15 years. According to leaks from Giga Texas, Tesla cracked it. The specific chemistry remains classified, but engineers mention a graphene aluminum composite cathode that handles mechanical stress without breaking down. Early testing allegedly shows 2,000 plus cycles with less than 15% degradation. If accurate, and Tesla doesn't leak specs unless production ready, this isn't incremental improvement. This restructures EV economics completely. Here's what the numbers mean. A 53 kilowatt-hour aluminum-ion pack weighs approximately 285 pounds versus 350 pounds for equivalent LFP. That 65-pound reduction directly improves efficiency. Range estimates hit 300 miles on EPA cycles, which seemed impossible for a pack that small. The cost advantage is more striking. Current LFP cells run about $80 per kilowatt-hour. A 53 kilowatt-hour pack costs roughly $4,240. If aluminum ion drops to $40 to $45 per kilowatt-hour through cheaper raw materials, You're looking at $2,120 to $2,385 for the complete assembly. That's over $2,000 saved on the single most expensive component. Suddenly, $14,999 transforms from impossible to calculated. Remove $2,000 from battery costs, another $800 from eliminating premium interior features, maybe $400 from simplified exterior design, and you're at a price where Tesla makes money while undercutting every competitor. But this raises a question: why announce now, with production months away? Tesla has a history of quiet development followed by dramatic reveals. They could have tested aluminum ion in limited production, refined chemistry, and launched in late 2025 with a polished product. Instead, Musk is broadcasting specs before customers can order. That suggests urgency. The design reflects this urgency. Tesla abandoned the light bar defining the Model Y aesthetic. Headlights sit higher, creating a more aggressive front that's cheaper to manufacture. It's a hatchback, shorter and lighter than Model 3, built with next-generation giga casting. This reduces the body to several large molded pieces instead of hundreds of stamped panels welded together. Fewer seams mean tighter tolerances and faster assembly. But hitting $15,000 required painful cuts. Fabric seats instead of synthetic leather. No heated seats in base models. No panoramic glass roof. You get conventional steel and single-pane windows instead of double-layered acoustic glass. Single-color ambient lighting. A basic audio system that's functional but not impressive. These aren't temporary measures. They're fundamental decisions defining what Model 2 actually is. The cheapest way to own a Tesla with acceptable performance. Some see this as miraculous. A $15,000 EV with 300 miles of range, supercharger access, and over-the-air updates. Others see fabric seats and missing features and feel cheated. Context matters. BYD's Seagull starts at $12,000 with cloth seats, basic climate control, and 190 miles of range. Model 2, even stripped down, includes full self-driving hardware, better safety systems, superior software integration, and an established charging network. You're buying the cheapest ticket into an ecosystem that includes autonomous capabilities, continuous updates, and eventual robo-taxi network participation. The exterior carries this utilitarian logic. Clean lines minimize manufacturing complexity. Reduced curves mean simpler stamping. Aerodynamics optimize urban efficiency over highway speed. Even doors reflect this thinking. Early rumors suggested falcon wing doors or exotic mechanisms borrowed from Cybercab. False. Cybercab uses experimental, unboxed manufacturing still being refined. Model 2 uses proven processes modified from Model 3 lines. Conventional four-door architecture with redesigned hinges for tighter tolerances. No theatrics, just doors that work. This is where Tesla walks a dangerous line. The company built its reputation on premium products with cutting-edge technology. Model S defined electric luxury. Model 3 proved EVs could be mainstream without compromising performance. Now Tesla launches a $15,000 vehicle with fabric seats and no heated steering wheel. Does this damage the brand? Every Model 2 becomes a visible reminder that Tesla makes budget cars now. That could hurt Model 3 and Y sales, erode resale values across the lineup. These are billion-dollar questions without clear answers. Musk's perspective is straightforward. Tesla's range needs to serve different markets. Model S Plaid exists for customers wanting 1,000 horsepower and zero compromises. Model 2 exists for customers wanting reliable electric transportation at affordable prices. Different products, different buyers. But the risk remains. Brand perception is fragile. Once you're known for making cheap cars, climbing back up market becomes exponentially harder. The December timeline adds intrigue. Tesla isn't promising delivery, just the unveiling. When Joe Rogan pressed for details, Musk said it could be the most memorable product unveil ever. Bold claim from someone whose Cybertruck reveal included smashing windows on stage. But the timing makes sense. December places the reveal at the end of a challenging year. Delivery numbers are down, margins compressed, competition intensifying, Cybertruck production messier than planned. Tesla needs positive headlines. A $15,000 EV with revolutionary battery tech and clear production path delivers exactly that. More importantly, December gives Tesla 12 months to scale production, identify quality issues, and reach meaningful volume by late 2025. That's critical because this isn't just launching a product, it's launching a movement. BYD builds roughly 85,000 vehicles monthly. If Model 2 will impact global adoption, Tesla needs 5,000 plus units weekly minimum. The difference between 1,000 and 5,000 per week is the difference between success and revolution. This brings us back to aluminum ion and why it matters beyond cost. Lithium supply chains are concentrated, politically complicated, and largely controlled by Chinese refining. Even deposits in Australia, Chile, and Argentina get processed in China before reaching manufacturers. This creates geopolitical vulnerability that worsens as EV adoption accelerates. Aluminum is refined globally, mined on every continent, outside any single country's control. If Model 2 succeeds with aluminum ion, Tesla doesn't just save money, they escape lithium dependency entirely. That's not a battery decision. That's strategic independence with implications extending far beyond one vehicle. And here's Musk's real surprise. Model 2 isn't just Tesla's cheapest car, it's the foundation for a post-lithium EV industry. If aluminum ion delivers on promised durability, energy density, and cost advantages, there's no reason Tesla couldn't transition the entire lineup. Imagine Tesla announcing in 2026 that all new Model 3 and Y vehicles ship with aluminum ion as standard. Suddenly, every competitor still dependent on lithium faces structural disadvantages they can't easily overcome. They can't match manufacturing costs, can't match range per kilowatt hour, can't escape supply chain volatility Tesla already solved. That's a competitive moat lasting decades, not product cycles. The $14,999 price shocks people today. The aluminum ion impresses engineers. But the real story is what Tesla is becoming. The only major automaker who solved the lithium problem before it became an existential crisis. So here's what just happened. Musk didn't just cut the price in half, he eliminated Tesla's lithium dependency entirely. The $14,999 Model 2 running on aluminum ion batteries isn't a budget vehicle. It's proof that Tesla solved the supply chain crisis before competitors even acknowledged it existed. While BYD and legacy automakers remain locked into volatile lithium markets, Tesla is building mass production vehicles with chemistry that's cheaper, safer, and completely outside geopolitical control. This is the inflection point. When Model 2 production ramps to 5,000 units weekly in late 2025, the entire EV industry will be forced to respond, and most of them are 5 years behind on aluminum ion development. What breaks first? Tesla's production timeline or material science limitations? Drop your prediction in the comments. If this breakdown gave you clarity on what's actually happening, hit the like button. Subscribe to Tesla Zone for more deep dives into the technology reshaping transportation, and turn on notifications. Because when Tesla starts converting their entire lineup to aluminum ion, you'll want to know immediately. The lithium era just ended. Tesla fired the shot. Now we watch the industry scramble to catch up.